In this Rhino Grasshopper tutorial, we want to model the trefoil knot in Grasshopper, and as you can see, I have modeled this by defining the equations. So you can see that this is basically the equations we're going to use to model that in Grasshopper. We are also going to change the equations to have the torus knot, which is actually another trefoil knot. And you can see by changing the equation, we can have that in Grasshopper easily and model this in Rhino. The last step is to model this trefoil knot in Grasshopper with a parametric way, which I'm going to explain. So you can see that by changing this parameter, which I'm going to explain step by step, we can have this in Grasshopper. You can see that I can change the rotation, I can change the distance, change the number of the knots. For example, I want to work on this one. Let's just decrease the pipe radius, and you can see that we can have this. We just made something, I guess, that no one has done before, because no one has modeled this trefoil knot parametrically with 5, 4, or whatever number of divisions we need. We just have to change the distance, and you can see that we can have that, or we can put that inside. This one, we just have to change the radius so they just go through. Okay, so be sure to watch the video till the end, and then we can give this a boundary. Let's just go to this ghosted, and you can see that you can have floors in this trefoil knot and use it in your project. So this is also an inspiration of using this Grasshopper thing to use the trefoil knot in some project. In this video, you can see that how you can make the trefoil knot by connecting the start and the end of a rope. And here we have that trefoil knot. Okay, so let's just get started by some basics. For a trefoil knot, you can see that the parametric equations is like this: x, y, and z. And we have to define this in Grasshopper, and I'm going to do that for the first step. So let's get started from scratch. And to make a parametric point in Grasshopper, it's really easy. You have to go to the vector menu and select the construct point. We have to make a point, put the bifocals plugin, and here we have the x, y, and the z. To make the x coordinates, I have to make a series of numbers. So I'm going to use a range. For example, here I'm going to use the range, and the steps is going to be the number of points we have. For example, we need just 200 of those points. If I give that to the x, you can see it's going to make 200 points between 0 and 1. The default is 0 and 1, and it's going to make it like here. Let's give this an equation. For example, if I go to the math section and select this expression, we can name this the t, and just zoom in and delete this one. And for example, you can see how easy it is to write a sine t in Grasshopper. Okay, so if I give this here, so if I give this to the y, and also by changing the y, I give the range to the x, you can see that we are making a sine curve. The next step is to control the domain. So it's from 0 to 1. If we wanted to control that, it's simply giving it a pi. For example, a pi here, it's going to give 1 pi of the sine. If we want to complete a sine wave, we can give it a 2 pi, and you can see that we have this. So that is really easy. You just have to define the equations and give it to the coordinate of the point. Now that we have understood the basics, let's just make this equation. So it's really easy to write the equations. We just have to make 3 of these expressions and give one of them to the x, another one to the y, and the last one to the z, and write the equations here. So let's just go and double click. I'm going to write this and show you the equations. Okay, so now you can see that we have these 3 equations written in Grasshopper. Just for the details, remember that you have to multiply with the star here So this is the first tip. The next tip is to put the brackets, so you can just type this equation in the expression section. Okay. Now you can see that we have this trefoil knot, the points in the space, and we just have to simply connect them. Go to the curve and interpolate them to make the curve. We can just turn off the points and we will have the trefoil knot in Grasshopper. If we want to make a pipe, we can simply go to the surface and connect a pipe to the curve and just give this a radius, for example 0.2, and you can see that we can play with this and have the pipe. So this is actually the trefoil knot, and we will have it in Rhino. Let me just connect a display custom preview to this, so you can see that with a color. Give it a material, and I usually connect a color swatch to the diffuse, so we can just give this a color. Another color swatch to the emission, I make it black, and then we can have a shine from 0 to maybe 30. By increasing the shine, it's going to show you exactly how it's going to be here. Okay, so the next step is to change the equation to this torus knot. I'm going to change that in these three equations and show you what's going to happen. Okay, so we have these three equations here. We can just copy this construct point, Control C, Control V, and make it with these three new equations. So I'm going to just connect that and turn off this one. So just have the torus knot. Okay, you can see that we can also produce that in Grasshopper and change the pipe radius to get the results. And we will finally bake that in Rhino to have the 3D form in Rhino. Okay, the next step is to make that from scratch. I'm going to explain this, so let's just get rid of this one or just turn it off, bring it a little bit down, and I'm going to make this a group. So if you want to download this example file, you can go to our website. For now, I'm going to teach you an advanced lesson, and that is how we can make this in Grasshopper, define some new parameters, because in this example we can't really change or play with these numbers. For example, if I want to go and change this 2 to 3, you can see that it's going to break the form. So this is not really going to help us to make the trefoil knot parametric. But before we move to the parametric knot, I'm going to show you some tricks you can use on this equation. For example, if I add another parameter and name it A, and let's just add each equation an A, and change these numbers. For example, if I add this to 3, these 2 to 3, and add this 3 to 4, it's going to work and produce a new knot. For example, if I start with a 2 and go to 5, we can name this an A. We can add that to here, here, and here. Okay, just replace these two with A. And this one is going to be A plus 1. So I'm going to just go here and name it A plus 1. Okay. So if I add this to 3, you can see we can produce a new knot, which is really beautiful. And I don't know what's the equation for this, but you can change that number. For example, if I add this another one to 4, you can see again another knot, and so on. So this is also the only thing I have figured out you can use in the equations to change the results, but the base one is 2, which is the trefoil knot. We need a new mechanism, which is actually a geometrical solution to this trefoil knot. Okay, if you look at the trefoil knot from the top, you can see it's actually 3 different modules with a polar array. So we have to pick up one of those to understand what's happening here, and then we can make that in 4, 5, or different number of counts for the polar array. The best way I know is to go to the surface utility and use this isotrim. So I'm going to use this isotrim here, give it to the surface, and then go to the math domain and pick up this divide domain 2. That is going to divide the surface into different number of divisions, and we can define how many count from u and v. Okay, for example, if I give a 1 to the u count, you can see it's going to give you 1 u, and if I give it to the v count, it's going to give you 10 u's versus 1, which if I bake this, you can see that the default is going to give you 10 divisions. That is actually what we want, 1 v count and then 3 of that u count. Okay, this is only to see what's happening behind the equation and remodel that in Rhino Grasshopper. Okay, so you can see that this is actually the 3 different parts of this trefoil knot. First of all, the base of the trefoil knot is, you can see it's the center from 0, 0, 0. If I look at the top, that is good. We can get started with this 0, 0, 0. I'm going to draw a line. First, I have to find the center of this circle, so I'm going to type DUP edge, duplicate edge, this edge, and this edge, and use the area centroid to find the centroid of this and the centroid of this, which is actually the location of the curve. We have the start and the end. Okay, so what I want to do here is to draw a line from 0, 0, 0 to here, and from 0, 0, 0 to that one, and this is going to give us a hint. This is actually 120 degrees. That's obvious because we need 3 of that. That is, if we wanted to type, it's like 360 degrees divided by 3, and we will have 120. So if we want 4 knots, 5 knots, we just have to divide 360 degrees with a new number, right? So that is the first parameter we can define. And the distance is also the same. So if I just put a line from here to here, you can see it's like 1 meters, and for here is also 1 meter. So the next parameter is this one, which is a distance we have to define. So first is the distance, the second one is a degree, which we're going to use in our parametric effort to make this trefoil knot in Grasshopper. Okay, the next part is to just take a look of this circle here. If you look at that circle, it's a circle in the YZ plane rotated. Okay, let me just explain that. So if we have a YZ plane, it has a little bit tilted back to have this circle, and for this one is also another plane in this direction. It's actually this direction, a little bit to the front, I guess. Yes, so if you just make a plane here, you can see it's a little bit rotated in the front. The degree which this rotation is defined is actually the same degree this is going to be back. So we're going to also define another parameter, which is a rotation. So we can say another one, beta, for example, and say it's going to go back. That is going to help us to model this in Grasshopper parametrically, and then make it 4, 5, or different knots we can control. Okay, let's get started from scratch, and we're going to go here and define a point. So I'm going to go to the vector, another construct point, put the bifocals plugin, and define the distance. So maybe 1 to 10 with 2 decimals. This is going to be our first parameter, which is distance. Okay, let me just rotate this. So it's going to go into X direction. I'm going to just simply rotate that one and go from here to here. That's going to give us a better view. For example, if I just select this pipe and type an array polar from this center 3 times, it's going to make the trefoil knots. Okay, so that's obvious that we have to make this module. You can see that by changing this point, it's going to change the location. To make the second point, we can simply rotate this point 120 degrees. So I'm going to type rotate and use the rotate 3D. The point is going to be rotated. The center of rotation is going to be here. So I'm going to also define another point, which is the center. We have to define a point here. This is the center of the rotation, and the axis is the Z direction. So we're going to actually rotate that in the Z direction, right? That is going to be the rotation. And the angle, we can just right click and define the degrees. For example, if I type 120 degrees, you can see that it's rotating in this direction. So we have to just give this a minus expression, minus X, and we are good to go. Remember that we had this 120 degrees by dividing 360. So I'm going to say 360 is the complete rotation. In the math, I'm going to divide that into 2 to maybe 10. Okay, this is the second parameter, which is count. And we can give that here. So it's 3 times and 120 degrees, exactly what we need. Okay, let's go forward. The next part is to define the circles. Why do we need to define the circles? Instead of circles, what I want to define is a plane. The plane is going to help us to use the normal direction to make the base curve, because this is just a pipe. We need the base curve inside that, right? So what we need here is to define 2 different planes. The first one is really easy. I'm going to go to the vector, and in the plane, I'm going to use the construct plane to make a plane. Okay, the origin is here. So let's just connect that to the point. The axis in the X direction is actually X. So I'm going to just put that X, unit X in the X direction. The axis in the Y is the Z direction rotated. So what I want to do is to just say Z to make it like that, and then rotate that a little bit back. So I'm going to say, again, rotate 3D, rotate the plane. The center of rotation is going to be the same point we had here. So let's just bring that up. That is the center of rotation. The axis of rotation is going to be the X. We can give that to the X. And we need a degree again. Just turn this off. For example, if I give this a 20 degrees, it's in forward. So I'm going to give this again a minus X. Now you can see that we can control this plane, right? This is the second parameter. So I'm going to say plane rotation. This is also what we need to define, so we can take the plane. That's it. Okay, we can also give it a real number, so we have some decimals to play with. Okay. Now we have to make that same plane here. So I'm going to just copy this down here. Remember that the plane rotation is the same, so I'm going to just connect this one also to the angle. But now we have to move the origin. The origin is going to be there, so we had it here. Let's just bring this down. The axis for the X is going to be in this direction. How can we do that? We can go to the vector and use this vector 2 point. The vector 2 point is going to be from this point to the point we rotated. That is going to be the X. Okay, delete this one. So this is going to be the plane, right? The y-axis was the z. Now we have to rotate it. This time it's going to be rotated around this axis, right? So it's not x. We have to give that vector again to the axis of rotation. And remember, the center has to be the center here. and turn everything off. Just a little bit of fixing those inputs, and now we can see that we have, okay, so if we go inwards for this one, it has to go outwards. So that is correct. You can see that this is exactly what we need, and we are good to go. That was the most important parameters: the count, the distance. So remember that we can also change the distance. I'm going to put that one to put that as the reference, and the plane rotation. The next part is to make the curve. I'm going to use this curve spline Bezier span, because the Bezier span is going to help us to give this start tangent, end tangent, and give it some magnitude. So the start is going to be the start point. We can connect a plane to the point, and it's going to help us to have the center of the plane. So that is really easy. Just give those planes to the start and the end. The tangent is really important. It's the z direction of these planes. Another trick you can use, you can go to the parameters and connect a vector to that, and that is going to give you the z direction. Another one to this one. So we have the z directions, but we have to multiply that with multiplication. So I'm going to just say multiply that with a number slider. This is also another parameter, so I'm going to say 4 tangents. Just write a number slider from 0 to 10, for example. And that was the last parameter we need. So it's going to be 4 tangents. Just give this a little bit of a number. We have to multiply both of them and give it to the start and the end. Just a little tweaking here. You can see that this is in this direction, so I'm going to put that -x here to fix it. To go inward, let's just take a look at this one. This is correct, so we don't need to change it. Okay, and now we can just play with this to get better results, right? Go to the ghosted one so you can see that. Okay, by changing these numbers, we can play and find the exact location of the real trefoil knot. But remember, you have to also play with this rotation. Remember that this is also the rotation here, and you can see that we can have that. Okay, that's how we can actually make it in Grasshopper. To the center of this point, I'm going to internalize that. Right click and internalize, so I can just get rid of everything and check it out. That's okay. Now we can change the distance, right? We can change the count if we want to, which I'm going to explain at the end, and the rotation of the plane, which is going to change the overall shape of the trefoil knot, and also the tangents. Okay, we can just simply make an array of this. So I'm going to say a polar array from these curves. The center is this point, remember. I'm going to give that to the center. And when you connect a point to a plane, it's going to assume that it's an XY plane again, and the count is going to be the number we just defined here, right? The count. So I'm going to give that same amount to the count, and we will have the trefoil knot curve. Just simply let's make a pipe from this. Give it a radius. Okay. To be sure that these pipes are correct and they are connecting, we can do an experiment. We can go to this surface and use this brep join to join these 3 different pipes. Remember that you have to flatten so they are all in one group. If you don't know about flatten or graft, you can check out this tutorial up here, which I have explained about flatten or graft. So now we have these 3 different pipes, and we have joined them. You can see it's completely giving us a one closed brep. If I bake this, you can see it's completely one. And if you don't have a seamless connection, they are not going to connect to each other. So remember that this is going to assure that it's completely right and correct mathematically. Okay, so another way we can check this out, okay, we can say connect a panel to this. So you always have to have a closed B-rep. For example, if I just come here and change the rotation, give it another number slider to this angle, you can see it's not going to connect and will not have a one closed B-rep. Okay, so remember that this is really important, that we have the same angles and they're going to connect. Okay, then the last part is to give this a little bit of a color. So I'm going to just turn everything off. And let's just do some tricks here. If we put that to 4, you can see that this is also giving us another trefoil knot. It's like 4 different pipes, and it's connecting to make a closed B-rep, exactly like this. If you don't want to have any intersections, you have to just reduce the size of this pipe radius, but you can see how easy it is to make this trefoil knot. Okay, what I want to do is to give different colors to these 4 different parts. Going to go to this display custom preview to connect that here, and now we need to give that different colors. We can go to this params menu, select this gradient. Let's change that to maybe this color. Okay, the lower limit is 0, the upper limit is 1, so we have to make 4 different numbers between 0 and 1. That's really easy. Just make a range. The default is between 0 and 1. The steps is going to be the same number we defined here. So if I give this a 4, you can see it's going to give us 5 numbers, because it's going to divide a 0 to 1 into 4 different steps, which is going to give us 1 number plus. For example, it's going to just give us 0. It's like 1, 2, 3, 4, 5. So we just have to make this 1 less than the input, and we're good to go. We can give that to this gradient. It's going to pick between these colors, and then we can give it to this material. Okay, let's just play with more colors so you can see that, or you can just go with the rainbows. I prefer to use this one, which is better to see the results. Okay, now it's time to check our different parameters and see if it's working. Let's play with the distance. You can see if I increase the distance, we can, that's really amazing. You can have new trefoil knots. I don't know what this is, but it's a little bit weird. You can see by increasing the tangents, we can get also new results by changing the plane rotation. This is actually another trefoil knot. I don't know what it's called, but you can see how easy it is to define different trefoil knots, because it's a because it's a parametric modeling of this mathematical model. You can see that you can just make that. Okay, so if I put that to 3, you can just decrease that, so it's going to go inside. If you just put it outside, it's going to also give you another one. You can change the rotation plane, and you will have different knots. Let's just go to the extreme and increase that to maybe 8 knots. We have to decrease the distance so they go inside each other. We have to also decrease the radius of the pipe. This is too much. They're going to intersect anyway, so let's just make that small as possible, and you can see that they are. Let's just play with these numbers. Okay, we have to decrease the distance even more, and here we go. You can see that it's not going to intersect. It's a complete parametric knot, and we have this closed B-rep, so it's completely closed parametric knot. and we can decrease the radius if we want to be sure that it doesn't intersect. So it's just playing with these numbers to get better results. Okay. I hope that this tutorial was useful. We just made something, I guess, that no one has done before, because no one has modeled this trefoil knot parametrically. Okay, so that was the tutorial of how to model a trefoil knot in Grasshopper parametrically and play with the parameters to make something new. Good thing about this is that you can even increase the radius to make something like this. If I increase the radius, it's going to give you something like this, which I guess it's going to be also useful in art or making something like a sculpture and those things. Another thing about this is that you can, let me just show you some hints about this. If I bake this in Rhino, I can go in the right click on the perspective and use the clipping plane and just rotate this like 180 degrees. And now you can see that by changing the clipping plane, we can have different variations of this knot, which is actually you can make and use that in different projects. Maybe it's even architecture, you want to make buildings from the trefoil knot, and then maybe use the contour, the objects, and move that from here in this direction, and maybe say 0.5, and then we can give this a boundary. Let's just go to this ghosted, and you can see that you can have floors in this trefoil knot and use it in your project. So this is also an inspiration of using this grasshopper thing to use the trefoil knot in some project. Okay, thanks for watching. Remember to like this video and share this with your friend. And thanks for watching. See you next time. Bye.